Okay, everyone, here's that extra review. I can't find it anywhere. Maybe I didn't even do the video. I thought I did. But here it comes. We'll get this out of the way. When the skier moves from point D to point A here, so you can see that their speed is going down while time goes on. Eventually, their speed ends up at 0, so it is A. Point C to point D, that's right here. The speed doesn't change, but time goes on, so it is B. Point B, right there. Speed is going down as time goes on. So right at point B, which is right there, that's maximum speed, because after that, the speed is always less. And 4, from the start of the graph to point B, getting faster and faster and faster. D, because it's a straight line almost up to there. What's linear? +2, +3, +7, +10.5, +1, +3.5. So, if I went up by 2 and I went up by 7, if I went up by 1 here, I would have gone up by half of 7, which would have been 3.5. Here I went up by 1. Here I went up by 3.5. Here I went up by 3. Here I went up by 10.5, which would be 3.5 times 3. So A is a linear equation. This one, obviously not. This one, up by 6, up by 2. Sorry, down by 2. Which means if I went down by 1, I would go up by 3. So if I went down by 1, it would be +3. So if I went down by 3, then this would have been up by 9. Was it? Yes. So B is also linear. A and B. Which of these is non-linear? Well, we already know A is linear. We already know B is linear. So we got to check C and C and D. We know C isn't, so we only got to check D. -2 plus 0.6, which means if I minus 3 minus 1 would be plus 0.3. So -3 would be plus 0.9. And you can see it wasn't plus 0.9. So it had to be C and D. Frozen computer. Cost of a taxi ride is $5 plus 75 cents for every kilometer. So it must be constant. It can't be this guy because this starts at negative cost. And it can't be this guy because this starts at like $1. It can't be this guy because it's a curve. It has to be A because it starts at $5 and goes up constantly. The domain here, domains are x's, 3, 5, 7, 9. 3, 5, 7, 9. What describes the domain here? -1 is the lowest number. +3 is the biggest number, and it's every single value in there. So real numbers greater than 1 and less than 3, because there's no equal signs. Determine the f of 4. The f of 4 instead of being x, it's now a 4. So it's negative 6 times 4 minus 2. Negative 6 times 4 is negative 24 minus 2 is negative 26. A, D, C. If the graph is not connected, it's discrete. A graph of continuous data. When comparing two quantities, a horizontal line. Domain and ranges here. So the domain of this guy is 1 to 4. And so I got to find over here, I need a domain of 1 to 4. Oh, there it is right there. So this is A. B, 1 to 3. Close dots. 1 to 3 and 1 to 3. Oh, there's 2 of them there, so I better check the range. 2 to 4. Oh, there it is. There's B. This one is 2 to 4. Or, sorry, 1 to 4. So that one must be C. And then that one's D. Right, the domain and range of each function. Can every single number be cubed and multiplied by 3? Yes. So x is all real numbers, which means y is all real numbers. I have to bake cookies. The oven needs to be at 350, and the cookies take 12 minutes to bake. So what is the domain and range? Well, at 0, the domain is the IV, which is time. Right? So the time the cookies take to bake is 12 minutes. So my domain must be 0, time, 12, because that's when I take them out. The oven needs to be at 350 degrees. Do I want the oven to change? No. When I put the cookies in at 0 time, the oven needs to be at 350 degrees. So my range equals 350, because I don't want it to change. This one, x squared minus 2 is my x's. Can I square every single number? Yeah, so x is a set of real numbers. But since it's squared, I can never have a value. My y values have to be greater than or equal to negative 2. Because once I go into the negatives and I square it, it's going to be positive. 0 squared minus 2 equals negative 2. So negative 2 is the lowest y value I would have. Describe a possible scenario. The blue part, she rides for 15 minutes at 8 kmh. She speeds up. Oops, sorry, I'll change color. You've already seen this one anyway. Purple part. She speeds up for, what is that, 15 to 30. And she travels 4 kilometers in, so she speeds up for 15 minutes to 16 kmh. And then let's get another color here, the red. She returns home at it's 20 minutes, 6 kilometers in 20 minutes. She returns home at 18 kmh. You've already seen this question. Cost equals 2.5x plus 3. B, that's A, B, it is a function because every input, which is a game, gives a new output, which is a cost. And C, 4 games, cost equals 2.5 times 4 plus 3, which equals $13. You've already seen the height of the hot air balloon. These ones you haven't seen. Graph it. Well, when he sells 10 tickets, so tickets have to be down here. Tickets. And profits have to be over here, because profits depend on the tickets. So, when he sells 10 tickets, he's at negative $30. Negative 30. 10. Negative 30. When he's at 20 tickets, he's at negative 10. When he's at 30 tickets, he's at positive 10. When he's at 40 tickets, he's at positive 30. And so on. Is it linear or nonlinear? It's linear. Because 10 tickets sold gives $20 profit. Is it discrete or continuous? That's B. It's discrete because you can't sell half a ticket. Can't sell half tickets. Ticks. The domain and range. The domain is 0 less than or equal to tickets less than or equal to 50, and the range is negative 30 less than or equal to profit, which is less than or equal to 50. How many tickets must be sold to break even? Right there. 10, 20, a little more than 20. How do you work it out? Well, it's got to be halfway between these two, doesn't it? There's 0. Halfway between those two is 25. So it's 25. And finally, Carl earns $40 for every fence he paints. Cost of paint is $16. Spends $6 on paints and is using a recycled paint tray. His profit is equal to the earnings minus expenses. So P is profit and F is fences. I put it in this order because the profit depends on the fences. He earns $40 for every fence he paints. Every fence costs $16, and he spent $6 when he started. So if he paints 0 fences, he's lost his $6, and he's bought $16 worth of paint. So his profit is negative 16 plus the $6, right? If he paints 1 fence, if he paints no fences, he's at minus $6 because he hasn't bought any fence paint yet. If he's at paints 1 fence, he loses that 16, but he still loses that 6. If he paints 2 fences, he loses 2 times minus 16, but he still loses that original $6. 3 times negative 16 minus $6. So the same as the 16 thing, right? So his profit must equal negative 16 times his fences minus 6. That's going to be a negative number though, isn't it? So we got to think about how to do this. So we're going to erase all this and look at the whole thing as soon as I can erase. You got to look at the whole thing. If he paints no fences, he's bought no paint, but he bought $6, so minus 6. Right? If he paints one fence, he's made $40, is positive, but he's lost 16, and he's lost 6 because he bought the paint brushes. So that equals 40 minus 16 is 24, minus 6 is 18, right? So his first one, he's lost $6, then he's at 18. The next one, he's earned $80, but he's lost 2 times 16 because he's had to buy the paint twice, but he still has only bought the $6. 80 minus 32 is 48, minus 6 is 42. Now you will notice I'm going up by how much? Negative 6 to 18 is plus 24. 18 to 42 is plus 24. So we just keep going. This one is going to be plus 24, which is 66. Then 90. Then 114. There's your table of values. What's the function? 24 times the fence minus 6 equals profit. There's your function. How much profit would he earn if he earned 15 fences? So profit of fences is that. P of 15 equals 24 times 15 minus 6, which is 24 times 15 is 240, 360, $354. And to earn a profit of 474, 474 equals 24F minus 6. 480 equals 24F. F equals 20. And then it's done. And I think that's the end, isn't it? Yep.